Okay, guys, this question was your assignment yesterday. Hydrazine and 2H4 is used as a rocket fuel. Hydrazine reacts violently with oxygen to produce gaseous nitrogen and water. Write the balancing chemical equation. So, who can answer this question? Okay, guys, if you know the answer, you could raise your hand. Okay.
Uh,
Yes, Yasin. Hmm.
N2 H4.
Okay, so just a minute to pick my pen. So yes, N2 H4. Yes,
And
plus
oxygen
plus
plus oxygen
what is the
O2.
oxygen? O2. Good. Oxygen must written O2 because it's diatomic molecule. As we said, all gases must be diatomic, so must write O2. We can't write just O. Yields
uh, nitrogen G
nitrogen
and N2G.
N2, and we're supposed to put G. And of course, here we don't forget that's supposed to write G beside oxygen also, and we should here the hydrazine. This hydrazine, okay, we don't know is it liquid or gas, but suppose it to be liquid, so we're gonna write L here, okay. So it will produce nitrogen and
Plus
plus
H2O
H2O, okay, that's war,
liquid.
okay, so H2O, and we're gonna put like L liquid, okay. So now we need to balance this equation. So is it that equation is balanced?
4
So
H2O
so how many nitrogen here
2
and here?
2
Two. So no problem regarding to the nitrogen, but how many hydrogen we have here
4
and here?
2
So which side must be increased?
uh, H2O
H2O. So what we
2
should do?
2
We're
coefficient
gonna put a coefficient 2. Excellent. So as we put a coefficient 2 like that, we have 4 hydrogen and how many oxygen now?
2
2 oxygen, and here 2
2.
oxygen. So it's balanced. Yes or no?
Yes.
Great work, Yasin. Okay. So anyone can't understand what we did and that question, guys? Anyone can understand this, guys? Okay, so today, inshallah, we're going to continue, okay, here, our lesson. So we took today about the significance, okay, of chemical equation. What does it mean? That mean what could I predict from chemical equation? And last time we said that the chemical equation actually could, or the formula equation could represent more details about the chemical reaction. It represents what are the reactants, what are the products, and the conditions in which the reaction could happen in, like for example, heat, pressure, okay, certain temperature, so on. And also to represent the state of matter, is it liquid or solid or gas or aqueous solution, and so on. So like this I could know from the chemical formula, but not all things I could know from the formula equation. I also could be able to know about the quantitative ratios. What I mean by quantitative ratios? That means I could know how much, or the simplest amount of each reactant needed to react with the other. What does it mean? That means the coefficients which we rewrite, the number that we write beside the chemical formula, like for example, 2H2O, it means we have two molecules of H2O, okay? And these two could represent the amount of the water needed to, for example, react with whatever the substance is, okay? So here the coefficient represent the amount, or represent the relative amount. That means I need these two water to react with blah 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 to produce whatever. So that coefficient is very, very important because it represents the amount of the substance needed to perform the chemical reaction. And also we could use, okay, this amount, okay, or this coefficient could be used to represent the ratio of the combination. Let's take an example to understand. Look with me here, guys, to this chemical equation. H2 gas, so hydrogen gas, react with chlorine gas, Cl2, to produce 2HCl. So from that equation, we could predict, or what we could know, we know now that what are the reactants, hydrogen and chlorine, and what is the product, hydrochloric acid, HCl. And we know that all of them are found in gaseous state, and there is no conditions or no certain conditions to the reaction for the reaction to happen. That's what we know, but already the numbers here give the coefficient number, the number which is, or the big number that's right beside the chemical formula. This one is very, very important, because from this equation we could indicate that 1 mole, which means 1 molecule of hydrogen, could react with 1 molecule of chlorine to produce 2 molecules of hydrochloric acid, okay, or hydrogen chloride. So here like this we have, that mean I get the ratio, that mean each molecule of hydrogen react with 1 molecule of chlorine, that means the ratio is 1 to 1, okay, or 1 hydrogen molecule could produce 2 molecules of hydrochloric acid, and 1 molecule of chlorine is needed to create 2 moles of uh, hydrogen chloride or hydrochloric acid, as you can. So here it represents the ratio, or represent the how they could react, or the amount needed to make a reaction. Is it clear, guys?
Yes, Mr.
Okay.
Yes, Mr.
So here also we could find, or we could say, as we know the ratio, we studied before that the mole of any substance represent what, the atomic mass of that substance. Do you remember this, guys? I know how to change from mole to the atomic mass, and how the atomic mass represents the moles. Do you remember this? We said that in the first quarter. Do you remember, guys? So for example here, as the same in that equation, we could find that we can say 1 mole of hydrogen react with 1 mole of chlorine to produce 2 moles of HCl. So if we know that the atomic mass of hydrogen is 2, so in that case, okay, we're gonna find that 1 mole of hydrogen equal 2 grams, okay, and if we know that the atomic mass of chlorine equals 70, okay, so like this we said that 1 mole of chlorine, okay, 1 mole of chlorine equal uh, uh, sorry guys, here I'm gonna write it to make it clear for you. We know that the atomic mass of hydrogen equal 1, okay, so that means 1 hydrogen equal 1 gram. So as 1 mole of hydrogen equal 1 mole of hydrogen equal 2 grams, because it contains 2 atoms of hydrogen, okay. Here chlorine Cl2, okay, 1 chlorine atom, its mass is about 35 gram, so that means the molecule of chlorine will be 70 gram. So like this I could predict that that's 2 grams of hydrogen needed to react with 70 gram of chlorine to produce, okay, to produce here 72 gram of hydrogen chloride. Okay, is it clear, guys? Is it clear, guys? So
Yes,
here, that the idea that 1 molecule of hydrogen, okay, that equal 1 mole of H2, so their mass will equal 2 gram. So here, white chlorine, we have 2 atoms of chlorine combined in 1 molecule. So 1 mole of chlorine equals 70 gram. Okay, so once they combine together, they are going to produce. Here, in that case, as we talk about grams and regarding to the law of conservation of mass, that the mass of atoms in the reactants equal the mass of the atoms in the product, which means the number of atoms that involve in the chemical reaction equal the number of atoms that already result from the chemical reaction. So here we could figure out that's not, it doesn't mean it's a reversible reaction. This arrow here, it means I could read it in both ways as grams or as molecules. That means I could say 2 molecules of hydrogen chloride could break down into 1 molecule of hydrogen gas and 1 molecule of chlorine gas. That means this arrow in the middle means equal. It's sort of like equal sign. That means the two sides, it's like algebra. The two sides are equal. So I could read it from any direction. Okay, you get this? Okay. That means I could read that 1 molecule of hydrogen combines 1 molecule of chlorine to produce 2 molecules of HCl, or I could say 2 molecules of HCl are combined or are produced from 1 molecule of Cl2 and H2. You get this, guys? So here, like this, okay, we said all these I could note, or I just could use the chemical formula to predict all these. But actually, the chemical formula still doesn't represent everything about the chemical reaction. Why? Because as we said, the chemical formula we could know, or the chemical equation or the formula equation could represent the reactants, the product, the conditions of the reaction, and even quantitative amounts or the quantitative information about the reaction. But still, we don't know, is it the chemical reaction could happen or not? That means if I said, for example, whatever, any chemical substance plus another chemical substance, I don't know, is this chemical reaction actually could happen in lab, or that means that could happen in nature, or this reaction cannot happen, because not all chemicals they could react with each others. Okay, for example, if I get piece of gold and I place it in hydrochloric acid, so that means Au plus HCl. So actually this reaction doesn't happen. Okay, but as a formula, or as an equation, I could write an equation, but it means I don't know this equation is actually happen or not. So the chemical equation doesn't represent, is it an actual reaction that mean could happen or not. So that's problem. But inshallah, in the next section, okay, and the section before that, we are gonna learn what are the types of chemical reactions, so we could know, or we could decide, is it equation is true or not. That means this equation actually represent an actual reaction, or it just an equation which is false and doesn't represent an actual reaction. So that's the fact here in the chemical formula. Also, there also in the, or the chemical equation, sorry, and the formula equation also, it doesn't represent the speed or the rate of the chemical reaction. That means it's already represent the reaction, but actually it doesn't represent, is it this reaction is slow or fast or whatever. Okay, so I couldn't predict the rate of the chemical reaction from the formula equation. So still some information about the chemical reaction is not known from the chemical formula, from the formula equation. We need to know it, okay, by studying the reaction practically in the lab. Okay, any other question here, guys? So now we're gonna pass to the last part here, balancing chemical equation. So once we talk about balancing the chemical equation, as we said before, the chemical equation should be balanced. What mean by balanced? That means the number of atoms which start the chemical reaction equal the number of atoms which are already produced from the chemical reaction. Why? Because, or to satisfy the law of conservation of mass. No atom can just create it from nothing or destroy it or disappear. It doesn't happen. So for example, here when we look at this equation, H2O found in liquid state is going to break down into H2 plus O2. Okay, so if this equation is balanced, of course it's not balanced. Why is not balanced? Because here we find that we have two hydrogen atoms start the reaction. We get two hydrogen atoms get out of the reaction, but we start by just one atom, okay, in the water, one atom of oxygen in water, but we end up with two atoms. Okay, so the question which all of you gonna think about, how I get two oxygen, I just have one. Why I can't write plus O, because we said O is diatomic gas, it must be O2. So how I get an extra oxygen if I just have one? So remember, as we said, the formula equation represent the simplest, okay, or the relative amount, not the absolute amount. That's not the real amount. That means in the reaction, when you are working, when you have a beaker containing water like this beaker, it doesn't just include one water molecule. Okay, it just contains millions of molecules, which means this O2, or this two oxygen to be released, must be released from two molecules. So in this case, I should balance the chemical equation by adding coefficient 2 before the water. So in that case, we are going to write here 2 like that. So once we balance like this, we're going to find how many hydrogen we have right now. We get 4 to multiply 2, it's 4. So we're going to put here another 2. And like that, we have 4 hydrogen in that side, and 4 hydrogen in that side, 2 oxygen in that side, and 2 oxygen in that side. So the equation now is balanced, which means we could say, or we could describe this reaction that each 2 moles of water, or each 2 molecules of water, they break down to produce 2 moles of hydrogen gas and 1 mole of oxygen gas, or 2 molecules of hydrogen gas and 1 mole, one molecule of oxygen gas. Is it clear, guys?
Yes, Mr.
Okay. Yes. So like this, okay, that's the idea of balancing chemical equation. Balancing chemical equation, also we need to practice how to balance the chemical equation, but there are some rules we should know about balancing the chemical equation. We never ever, okay, change the subscript. Subscript is fixed because they are a part of the chemical formula. For example, H2O, that water, so I can't remove the 2, because once you remove the 2, there is nothing called HO. So like this, you already changed the chemical formula. And as we said, one condition or one characteristic of chemical equation, that it must represent a fact, that it must represent a real chemical compound. So I can't change the subscript. We only balance chemical equation by adding coefficients. The lowest coefficient we use is 2, and we could increase whatever the number there's to ensure that the two sides are balanced. But the balancing of chemical equation B must be in the simplest form, which means that we should make it set. That means I could write here 4 and here 4 and here 2. That will be wrong because we need it in simplest form. So we need to simplify. That means we're going to divide by 2. So let's take a kind of practice to be sure about this, guys. So here, let's find this. He asked you, let's try to balance this chemical equation. Okay, he said that zinc plus H, that one, yeah. So let's try to balance this chemical equation, guys. Okay, so here we said that Zn in solid state reacts with hydrochloric acid in aqueous solution to produce zinc chloride plus hydrogen gas. So how could we balance this chemical equation? Is it balanced? No, it's not balanced. Why it's not balanced? Because simply we find that we have just one zinc atom, and here we're just one zinc. But here we have 2 chlorine atoms, and here just 1 chlorine atom. So it's not balanced. What we should do here, guys? Who can answer the question? How could we balance this equation? Guys, let's think here. Just we have 1 zinc, and here 1 zinc. No problem. Put 2 where, Hassan?
In the beginning, I put 2 also in the beginning with the first one.
Here?
Yes, and in the
if I
other
put 2 here, just wait, Hassan. So Hassan, how many zinc we have here?
1,
And here?
1.
1. So no problem in zinc. So I don't need to change the coefficient of zinc. Let's see here. How many hydrogen do we have here? Hassan, how many hydrogen do we have in HCl?
1. Yes, we should
Yes.
put the 2
And
before
here
the H.
we have 2. So in that case, we should put 2 here because we have 1 hydrogen atom here, but 2 hydrogen in that side. So like this, we need to increase that side, okay? So in that case here, we have 2 HCl, which means 2 of hydrogen and the 2 of chlorine. Okay, so let's test. How many chlorine do we have here?
2.
2. So now the number of atoms before the reaction or the reactants equal the number of atoms in the product. Yes or no?
Yes.
Yeah, so like this, it's balanced. Is it clear, guys?
Yes.
Okay, is it clear, guys? We know how to balance the chemical equation. Guys, is it clear? Okay, so let's try to, right here, he said that, let's try to practice more. Here it said, write the word formula and the balanced chemical equation for each of the following reactions. Solid magnesium and aqueous hydrochloric acid react to produce aqueous magnesium chloride and hydrogen gas. So who could answer these guys? Okay, who could answer this question? So just Yassine, every time he's gonna speak while the others not, and you expect that you get all your participation marks. Okay, Yassine, start.
Magnesium
Yep,
plus hydrochloric acid
yep.
yields
So
magnesium
yeah,
chloride.
you're talking about the formula, yes? So we're gonna say, yep. So here we said magnesium, okay, yes. Which one? Oh yeah, magnesium plus
hydrochloric acid
yeah, okay, yields
magnesium chloride.
So of course, because I can draw an arrow, so we're gonna say magnesium chloride. Yes, plus
And hydrogen plus
hydrogen.
hydrogen.
Okay, that is the formula. Good. Now we need to make it as formula equation. That is a word equation. We need to make it as formula equation. So what we're going to do?
MGS.
So just sorry guys. So here we're gonna use Mg, that is magnesium, good. And we said in
S.
solid state, so we're gonna write S between brackets, good, plus
HCl.
hydrochloric acid, which is HCl, good. So yields.
AQ.
So this one we are gonna write AQ because it's aqueous solution, good. Okay. So what the result will be?
MgCl.
MgCl plus.
It's aqueous also.
So that's AQ, okay. Plus
H2.
H2, which is gas. Yes or no?
Yes.
Yep. So actually, is it chemical equation is true? No, it's not true. We have two mistakes. What the mistakes we have? First,
Hydrogen.
no. First here, this one, magnesium chloride. We should be sure that the chemical formula of each chemical substance is true. Magnesium chloride, magnesium is Mg. Its valence is 2 because it's divalent in the group 2. Chlorine Cl and its valence equal 1 in group 7 halogens, so it needs to gain 1 electron. So like this, we're gonna switch places, so it will be Mg Cl2. Okay, so the chemical formula must be MgCl2, not MgCl. Okay, so that's the first. Then we check the chemical equation is balanced or not. Here we have one magnesium, and here we have one magnesium. Here we have one hydrogen, but here we have two hydrogens. So in this case, it's not balanced. Yes or no?
Yes.
So what we should do,
Yes.
Yassine?
2 coefficient
So we
hydrochloric
must
acid.
write a 2 coefficient here. So in that case, we have 2 hydrogen here and 2 hydrogen here and 2 chlorine here and 2 chlorine here. So like this, it's balanced. Is it clear like this, guys?
Yes.
Is it clear?
Yes, Mr.
Okay, so the rest of the questions in that part, okay, that will be a homework for you, okay? So we need you to answer this. Okay, I'm gonna check it. Please, after you answer them, please send the answer on the WhatsApp group, okay? And also, you're gonna answer, okay, here, this part also. So you're gonna this one, okay, this practice. So you're gonna answer this to practice and send the answer in the through our WhatsApp group to check your answers. And next time, inshallah, we're gonna check these answers together. Any hard question? We already finished our section, guys. Any hard question?
No.
Everything is clear?
Yes, Mr.
Okay, thank you.